And if you didn't do that yet, we ask that you follow the link in the chat and do that now. So we kind of, well, we're going to give you the pre-survey, which kind of touches on questions of what we're going to talk about. And then at the end, we do polls that have the same question. And we use that information to help us guide whether you guys are getting what we're talking about. And then it also, that data, as we all know, can help with grant funding or any kind of funding in the future to show that this is actually helping the community and people are learning something, hopefully. So I'm going to give you guys a little more background while we're working on that survey. Feel free to do it at the same time. So the Maui Mauka Conservation Awareness Training was started to kind of connect tourism professionals with conservation professionals. So I used to be a hiking guide way back in the day. And when I started working in conservation, I was like, oh my gosh, this is a treasure trove of great information that people that visit here should know about. So we started this kind of unique relationship, kind of wanting to create a mutually beneficial relationship between tourism and conservation. And we wanted to base ourselves solely on the Mauka regions, just because a lot of tourists come here, they go to the beach, they go out in the boats, they go snorkeling, but they don't always spend time in the mountains and don't always know about what exists up here, like our forest birds and unique plants and animals. And so we kind of focused on the Mauka area. And with that, we have 3 organizations that work together to create this, which is East Maui Watershed Partnership, who I work for. There's today we have Serena with Maui Invasive Species Committee and Lissa that will be joining us. And then we also have Laura with Maui Forest Bird Recovery Project. And then a few years back, we started including guest speakers because we are not the only conservation groups on the island. There's many, 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 many awesome conservation groups, and we want to include them too. And so that's why today we have our guest speaker, Taya Penniman from Birds Not Mosquitoes with the American Bird Conservancy. And that changes every time we do this training. So again, we said we're Mauka based, and we're Mauka based because of the mountains. The mountains are important because they help collect rain. And so I'm kind of going through our logo here on the screen because we've created this logo to help kind of remind people about what we're talking about today. And so we're focusing on the mountains, and the mountains have trees. And a lot of these trees help create rain. So you see the raindrops and the A's, but we have trees that are found nowhere else in the world. And trees are also important because of birds. We have birds, and they create habitat for birds and other things that are also found nowhere else in the world, but they're threatened. And that's our little rat that comes in. And humans have introduced thousands of new species. They're a serious threat. And so then we want to think about what can we do? So then we have the canoe on the bottom, because there is a saying in Hawaii, Mo'olelo, that says, he wa'a, he moku, he wa'a, which basically means the canoe is the island and the island is the canoe. And we're all in this canoe together. And we've learned very recently in the past year that we need to really take care of it because we're all here together. We are pretty isolated. And so together we can kind of really work and create sustainable tourism, hopefully, and include conservation in some of our tourism and topics. So with that, I'm going to have Serena. If anybody has questions, go ahead and type it in your chat. But we're going to have Serena from Maui Invasive Species Committee do a quick little background of the history of the islands and the ecology, just kind of get a big background for anybody that's not aware of it. So, thank you.
All right, mahalo, Allison. Let me just get my screen up. You guys get to see my messy desktop.
Sorry, we have a poll, Serena. While you're working on that, I forgot.
Perfect.
So while Serena's getting her her slideshow up, you guys probably saw a poll pop up on your screen. If you guys wouldn't mind answering that while we're kind of transitioning here, it's good information for us to know. Thank you.
All right. Did you want to share the poll results?
Sure, I
Alice?
think it's kind of fun.
Oops.
So we've got 22 and 25. So we got 3 more people. And then, yeah, we can share it so people kind of know who's here.
Can you hear me? I'm frozen.
I can hear you, Serena, and I can see your presentation as well.
My screen is frozen.
Hey, Serena, I had to do the on the screen, click the bottom buttons on the presentation itself to advance.
There we go. Okay. Well, yeah, my whole screen just froze and went black, and now we're back. So let's just hope that it stays. It stays up. All right. Can you guys see me and hear me?
Yes.
All right. You ready for me to go?
Go.
All right, awesome. Okay, well, aloha everybody. Mahalo nui for joining us today. My name is Serena Fukushima. I'm the Public Relations and Education Specialist for the Maui Invasive Species Committee. And I'm going to do a very brief, quick introduction about the natural history of the Hawaiian Islands. This is, millions of years in about 10 minutes. So bear with me. But I love talking about this. This is the root and foundation of why I got interested in the conservation field, because of just the amazing abundance of endemic and unique species here in Hawaii, and what drives me in protecting them through my work in invasive species. So without further ado, let's get started. So here in Hawaii, we are the most isolated island chain or isolated landmass in the entire world. You couldn't tell that now with our smartphones and our global connections, but we are really out there. And our closest continental landmass is 2,500 miles away. So geographically, we are out in the middle of the largest ocean on our own. Our Pai'aina or archipelago is fairly young geologically. Our most northwestern Hawaiian island, Holaniku or Kure Atoll, is about 28 million years old. In the formation of our Pai'aina, Pele moved her way down in forming Papahanaumokuakea into our main Hawaiian islands and is still active today, creating new land in Hale Maui as well as Lo'ihi, which is our newest island that's still underneath the ocean surface. So 28 million years old sounds pretty old, but in geologic time, we're still fairly young. We're about here in the whole scale of the Earth's formation. And this makes things pretty special in how we have our endemic and native species that are here in Hawaii. So we talked about the age of Hawaiian Islands, but we are volcanic islands. So the lava came out through the floor of the ocean up into our shield volcanoes and created this foundation in this aina that we have here today. Also don't want to leave out the rich mo'olelo that we have in our creation as well through the stories of Pele, as well as how Maui brought the islands out from the ocean. So those are really important, I think, to integrate, especially for our friends in the tourism industry that are joining us today. Having those mo'olelo incorporated along with that geologic history is really important in telling our full story. So our islands were created And then after some time, one new species arrived here every 3 to 5 million years. And so these species didn't have, a cruise ship to jump upon or airline. They came here through three main ways. And if you're familiar with the 3 W's, I like to flip that into the 3 M's. It is Olelo Hawaii Month. So honoring our Hawaiian language is really important to me. So our 3 W's or 3 M's are wind or makani. So species came here through getting blown in on storms or traveling on jet streams to arrive to our islands. We have moana or water, our deep ocean. Other plants and animals got here through drifting and currents or again through storms getting pushed over. And then manu or wings. So birds also flew here and brought seeds and new species in their bellies that came to our islands and established. So these species arrived, they utilized and adapted to different climatic and ecosystem zones. It's really important to note that Hawaii has 10 out of the 14 ecosystem zones in the world. And so we have really diverse climates and niches that these species settled into. From these ancestral species, only the strong survived. So the first journey for those initial ancestors that established here in Hawaii had to essentially adapt and learn how to live together and get along. And many evolved into many of the species that are only found in Hawaii today. So that extreme isolation and that low rate of colonization led to this unique set of plants and animals that we have here. And we have some of the highest rates of endemism in the world, meaning that, again, these plants and animals are found not only in Hawaii, but sometimes in just specific parts of our islands. These single ancestor populations resulted in a high rate of mutation, and combined with those ecological niches within that close proximity to each other led to evolution of these many different species that we see. That process is called adaptive radiation, where one single ancestor evolved to become many different species that took advantage of the resources that were here. So one example is the finch ancestor that arrived in Hawaii that radiated to many different species of birds that we have. And Laura and Taya will talk a lot more about that later today. So another interesting part of these this evolution process is that these species lost their defenses against predators. We actually only have 2 native land mammals, but other than that, we had no other grazing animals or predators that these ancestor populations faced on the continents. And so why put the energy in making these defenses if you don't need them? One example is our mintless mint. That mint flavor is what deterred predators from grazing on it. And in Hawaii, it didn't have it, so it lost it. And that's just one of the many adaptations that our plants and animals had. They also had to evolve together and work together and form relationships together, like our EEV and many of our flowering plants. So if you notice, the EEV's curved bill is adapted to feed on the nectar of this mintless mint and other flowers, thus to feed itself as well as to pollinate the plant. So I like to think of it, we all live on islands, we're island people, we need to get along together, we need to work together, and that's no different in our ecological and environmental world as well. Relationships are very important. And Kanaka Maoli also recognize these relationships as well. And we see that in the Kumulipo. So the Kumulipo is one of our creation and progeny chants that was first written down by King Kalakaua after it was passed on orally for generations. And in the Kumulipo, we see that many of these species are listed from Mauka to Makai. And there's intrinsic relationships or pilina that are created within these chants and that were observed. And it is important to note, since we are, talking from a reference of Mauka, that the plants and animals of Mauka were the kia'i, or they're the protectors and the guardians of the things down Makai or in the ocean. So these are just a few examples on my screen, but definitely encourage you to check out this text to learn more. So like I mentioned, there were no grazing land mammals, but we do have 2 native land mammals. We have the Hawaiian monk seal, as well as the Ope'ape'a, or the Hawaiian hoary bat. We also have only 2 native reptiles, our green sea turtles, and our hawksbill sea turtles as well. But other than that, there were no native reptiles, amphibians, mammals at all in Hawaii. So I've been talking a lot about native, non-native. Terminology-wise, native is a species that arrived here without the aid of humans through those 3 M's or 3 W's that I mentioned. Indigenous is something that's found naturally in an area, but also in other places in the world. So one example is beach naupaka, which is indigenous to Hawaii, but also found in other places in the world. And then endemic is found naturally only in that area. So our nene are endemic to Hawaii, our pai'aina, our archipelago, but our ahinahina or silver sword are endemic only to Haleakala. Even the silver sword in Mauna Kea are endemic to that specific mountain. So really incredible niche adaptation and evolution. So fast forward to today, species are arriving a lot faster than they used to. Now they do have airplanes and mats and ships and boats to get on. They come from all over the world and arrive here faster and in even better condition than before. So they're pretty much getting their first class ticket over to Hawaii. From 1 species every 3 to 5 million years, we are now having 1 new species arrive in our islands every 3 days. So it's a pretty high rate of introduction at this point. Non-native species arrive directly or indirectly because of humans. And so we have our first Polynesian introductions, which are species that Hawaiian settlers brought over for food and medicine, often called canoe plants. Naturalized species are introduced species that have become established and are reproducing in our environment. And invasive species are those that cause harm to our human health and environment as well. We're currently facing threats against our native ecosystems and species. Some of the main threats include habitat loss, those introductions that we talked about, specifically invasive plants and animals, the introduction of predators and disease such as these avian diseases that Taya is going to be talking about today. Climate change is also another factor, unfortunately, to our native ecosystems. And I love this map, but the transition is heartbreaking. So this is what our native habitat looked like 200 years ago here in Maui Nui. And in just that 200-year time, we've gone from a primarily native habitat to what we have left now here. And so this is part of the things we talked about that's contributing to this massive change happening. Some of these things include non-native feral ungulates. They're major ecosystem disturbers in our Hawaii environment, and they do not benefit native forests. An ungulate is a hooved animal. So some of the ones that we have here are goats, deer, pigs, and cattle. Non-native competition is also caused by other introduced plants and animals that essentially just take over in monotypic stands, like you see with the Himalayan ginger on the top left. Myconia is another highly invasive competitor that shades out native plants from growing in the forest. And then we also have mejiros or other animal species that compete with our native bird species. Our non-native predators, again, remember native species were not adapted to defending themselves against predators at all. So they're extremely susceptible. And we see that in the cases of cats, rats, and mongoose, especially in decimating our native bird populations. Also introduce snails that will unfortunately attack and eat our native snails. Introduce diseases, which we'll go into a lot later, but that is also a huge contributor to our native plant and animal decimation. We see avian pox and malaria, which Laura will talk about as well as Taya, and then also introduce funguses and pathogens like Rapidohea death, which have the ability to disturb native species populations on a huge scale. All right, so I know this is really sad, but there's hope, I promise. So unfortunately, though, we are the endangered species capital of the United States. Hawaii has the most threatened and endangered species in the US and per landmass in the world. So we are unique in the sense of our high rate of endemism, but that also goes hand in hand with with this endangered species statistic. Now with climate change, we're facing even more impacts now and in the future. We are facing higher rates of wildfire, regional temperature increase and shift in precipitation, which can lead to drought, which we've been seeing and experiencing here on Maui, as well as changing the location of the mosquito line that allows mosquitoes to go further and further and higher in elevation where our native birds have not had to combat or deal with them before. We talked about diseases that impact our species, but with climate change, we could see even more disease and insect outbreaks, and also with sea level rise. So kind of a scary future to look at, but there is hope. So out of all of our landmass in Hawaii, 800,000 acres are in some sort of active conservation management. With our 2.9 million visitors annually, when 66,414 visitors per day to our 168,000 residents, your interest alone in joining us today, to our visitor professionals, your interest in this training and your effort in learning and wanting to share this makes a huge impact and is a huge contribution to Hawaii conservation. Also, the people that are here that are in the conservation field, we have to all work together, and your impacts and your efforts are amazing and is what gives us hope, as well as our future generations. And we're seeing a lot of young people really getting passionate, getting involved, and wanting to continue these efforts. So there is hope. But with that, I will hand it back off, and I think we'll take a break. But mahalo nui, everybody. And I guess if there's any questions, we can answer questions while we're on the break.
Okay, I'm gonna get my screen up. Okay. And you guys should see my screen up there now. I'm gonna make sure you guys got my sound for when I play a video. Wouldn't that be fun? All right. So my name is Allison, and I work for the East Maui Watershed Partnership. So looking at my slide there, you can see that colored area. That is basically all of the East Maui Watershed Partnership. Now, the partnership was created back in 1991, and it was mostly the major landowners that got together that decided, hey, we can get more large-scale conservation work done if we work together than apart, because invasive species and forest animals and things don't really recognize boundaries. And so they came together to create the partnership. It's just over 100,000 acres. And the partners that are included is Haleakala Ranch, the state of Hawaii, Haleakala National Park, East Maui Irrigation, the Nature Conservancy, and then the County of Maui. And you'll notice the County of Maui in our little map is not a landowner, but because we help protect one of our largest recharge areas for our water supply, they are also a partner. On average, this area of Maui on the windward side of East Maui provides up to 60 billion gallons of water a year. So it's a major source of fresh water for our island here. We are not the only watershed partnership. There are 3 on Maui. So there's also one on the west side called Mauna Kaho'olawe Watershed Partnership. There is one on the leeward side of Haleakala called Leeward Haleakala Watershed Restoration Partnership. And there's 10 throughout the whole entire state. So the idea of all these people working together really spread and has been working really well across the whole state. So we got to ask the intro question of what is a watershed? And so oftentimes when I ask this question, I often get oh, it's the shed that holds the water. No, it's not the shed that holds the water. It's the area of land that collects the water. And so if you're looking at the island, basically, usually the different valleys are where the water is going to end up collecting. So if it's raining outside, that water is going to go from the highest ridge points on either side, the top of mountain, all the way out to the sea. And that whole valley there where the water collects down in, and it will usually go into the stream. Sometimes it will soak underground into what's called our groundwater, is one watershed unit. So pretty much anywhere you are on land is going to be a part of a watershed. And the whole idea is if we take care of these individual watershed units, we're going to have fresh, clean water from now into the future. And I'm assuming that we all are really concerned and want to make sure we have fresh, clean water from now into the future. So this also follows the ancient Hawaiian land division system of Ahupua'a. So I always say the Native Hawaiians were way ahead of their time. They got it. They took care of these communities and these individual little valley systems, which was also coinciding with the watershed. So with my definition in your head, I just want you to think about whether or not you would say yes or no to this question. Are we in a watershed right now? And you should say yes. No matter where you are on land, you're a part of a watershed, okay? This is a map of all the watersheds on Maui. You'll notice there's a lot more on that windward side where we get a lot more rain. And in total, there's 113 watershed units on Maui. There's about 24 on West Maui and 89 on East Maui. And these forested areas that are native forests actually help us provide 50% more water than non-native forests. And the reason it can do that is we want to see layers in a forest. So we're just going to kind of step back and explain the whole forest system here. But in a healthy forest, let's say you're going out hiking on the trail, you want to see all these different layers. You want to see a band of tall trees that are helping slow down the rain. So when it rains outside, it's not impacting the soil and running off and creating erosion. It kind of slows it down, gives you that nice little trickle drip, very pleasant. And then there's that sub canopy, and this is super important because that sub canopy, this is all the trees in the middle, help collect moisture from clouds. So when you're looking at the mountains and you see that lay of clouds hanging out up there, you can be like, yes, we're getting water from our cloud drip. And 30% of our water that we get out of our tap comes from just this process alone. And then you've got understory and ground cover, and these two things act like a giant sponge. They keep things humid. They actually soak the water, keep it in the ground versus evaporating and transpiring back out into the atmosphere. So they really help collect more water into our watershed. So I'm going to repeat what I said before, that we get 30% more water just by fog and cloud drip alone. So we definitely want to make sure that we have all these layers, because we could lose 30% of our water if we just lose that middle layer of our forest. So in comparison here, you can see the native forest on the left has all those layers I just talked about. And on the right-hand side, this is our non-native forest. This is actually a forest full of strawberry guava. And unfortunately, this is what we call a monotypic forest. The only thing that's growing there is strawberry guava. Just the tall canopy trees. We don't have a middle layer. The ground covers nothing but leaf litter. That's not what you want to see. That forest is actually using more water than our beautiful, nice native forest off to the left in comparison. So strawberry guava is a huge invasive species for us that we work to try and get rid of in our native forests. And so if you're traveling out towards Hana and you're passing by Ko'olau Gap, this is a great opportunity to point up there and start talking about it. Because my picture you can see there, that yellow line's pretty imaginary and drawn in, but the majority of all of the trees below are dominant with strawberry guava, and pretty much above that is mostly native forest. And the strawberry guava is creeping its way up into the native forest. It spreads very easily, mostly by feral pigs. And these trees actually use up to 25% more water than our native trees. So they are not good for our watershed areas. Also, a nice little fun fact is if you're traveling out towards Hana, you can at certain point up, you can see the map there. where we have that square and that kind of corner of Haleakala National Park and the Hana Forest Reserve. There's an area called Big Bog. There's a picture of it there. And this now receives the most amount of rain measured in the state of Hawaii and parts of the USA. So if you look at 30 years of collection of rainwater to this area, it has averaged 404 inches of rain, which is the most out of anywhere in the state and the US. Now, I know a lot of people are like, well, what about Mount Waialeale on Kauai? I thought that was it. That averaged about 384 inches over 30 years, and Pu'ukukui at the top of West Maui was 365 inches. So there may be wetter spots out there in the world, but out of the ones that are measured, this one takes the cake. So kind of a fun thing you can share with guests as you're driving out that way. So another cool thing to know is that from 270 original colonizers, over 1,000 different plants evolved. And we have a lot of unique things that are found here and nowhere else in the world. And one of those that I really want to point out to you guys is ohia. And so you guys will see that we have little infographics that we've put into the chat window. There's a lot of really unique plants. I'm just focusing on ones that people that you have on a tour or something or might see. And so on the back of that infographic is a focus to one of these trees. And this is a pioneer species. It can grow up through the lava rock. It can grow up low elevation, high elevation. Was probably one of the first things to come here and grow. And it's the dominant tree in our native wet forest. So high elevation forests that a lot of us don't always get to visit. This makes up about 80% of our wet forest canopy. And there's a lot of cultural aspects that go along with this as well. And when you guys get that follow-up email, Sam Ohugan, who's the cultural advisor for the Nature Conservancy, has a really nice YouTube video that kind of summarizes some of the cultural aspects of the ohia. And I will let him give you guys that information rather than me. And so if you're interested in that, you should check that out. And then Serena will also be talking about some of the invasive species and diseases that are affecting this tree that are super important. But also people like to hear stories, and there's of course the mo'olelo that goes along with this tree, that if you pick the flower, it's bound to rain. And I think a lot of that is because it is found in a lot of our native wet forest areas. Another key tree to know about is koa. Of course, a lot of us know koa because you can use it for woodworking, and it's a beautiful hardwood, but it has a really unique adaptation that it did amongst its leaves. And so if you look at my little picture down in the left-hand corner here, I don't know if you guys can see my mouse or not, but you see the little leaves on the end there, those are what's called the true leaves. And then you can see the stem starting to flatten out, and what looks like would be at the top of the canopy, the kind of older growth. And that is actually not a leaf at all. It's called a phylloid, and that is a modified leaf stem. And the modification really helped that this is one of the tallest trees in the forest, that its surface went from horizontal to vertical. So again, that fog drip coming in is now condensating on the flat leaf surface. And then the shape of it's real sickle shaped, which kind of directs the water towards the tip of the leaf and down to the roots of the tree itself. And so I noticed today we have a lot of conservation people in our audience. So I'm sure this is kind of repeat for some of you guys, but always fun to know. And then another plant that guests often see, or tourists, is our beach naupaka. And it's kind of fun to be able to tell them that, hey, although we have this native beach naupaka, which is indigenous, which means it's found here and other places in the world, we have 9 varieties of this plant that have spread up into our mountain that are found there and nowhere else in the world. And basically the differences too, as you can see at the beach, or the kahakai, which is the beach version, it's almost like a succulent. It says it's growing in a more dry area. It really has that succulent type leaf trying to collect as much water as it can, where when you go up to the mountain, it has the drip tip leaf again, where it gets a lot of rain, so it has a different variety. The fruits are different too. Beach variety has white, where the mountain variety has a purple fruit. But you'll also notice the half flowered. And there's a legend that goes along with this that a lot of people like to hear about the two lovers that were separated, one down at the beach and the other one found down up at the mountain. You can kind of look that legend up online. There's tons of different versions of it, but kind of helps people connect to it if you're out on a tour or something like that. This is another important plant, our silver sword, which a lot of people see up top at Haleakala. But it's interesting for people to know that there is an ancestor. It evolved from some 5.2 to 8 million years ago, and that's the North American tarweed that came from the West Coast. So that's that picture in the middle there. And depending upon where the seeds of this floated off to, it either became our well-known silver sword, which is basically adapted to harsh desert-like conditions of heat, sun, and wind. And it could also be in a wetter area where it's known to be a bog species. And here it's adapted more to moisture, lack of sunlight, and cool temperatures. And so it's kind of neat how, depending upon where these different seeds or species landed, they adapted particularly to a specific area and how to survive just right there. The carnivorous caterpillar is a really fun one for people to know about, because here in Hawaii is the only place in the world where we have 18 of our 20 native Hawaii species here became carnivorous. And most all other moths and caterpillars are all green eating plant materials. But here in Hawaii, we have some that eat meat, basically. And they think it evolved from eating protein-rich flowers and kind of filling a niche that was there with these insects. And so I'm going to play a little video so you guys can see it in action. But they do become moths. So here's a picture of some of the species as they turn into moths. And then I'll play my video here. And this video is available on YouTube. So if you want to share it on your page, because it's kind of fun. Let's see.
Let's face it, most caterpillars already look pretty strange, but their behavior isn't. Larvae of both moths and butterflies, most caterpillars spend their short lives inching from leaf to leaf, munching on vegetation. But this caterpillar isn't a vegetarian. It's a professional killer. On the island of Hawaii, 18 of the 20 native species of caterpillar have evolved into carnivorous predators. Perfectly camouflaged and armed with sharp, pincer-like claws, the larva cuts a channel into the leaf and waits. Other species mimic twigs or leaves, and these unsuspecting fruit flies never had a chance. No one knows why Hawaii's caterpillars turned into insect eaters. But one thing's for certain. In the evolutionary soup of isolated islands, it's easy to dish up something bizarre.
All right, so that's our carnivorous caterpillar in action. There's actually ones that are pretty much almost endemic to each island. And the way they found out it was carnivorous is they had found the caterpillar, and Steve Montgomery, who was researching it, put it into a little vial with a fly, and the fly disappeared. And he was like, wait a minute, what happened to that fly? And that's how they found out. So another unique thing is that out of our native flowering plants, 90% of them are endemic. So if you guys remember what Serena was talking about, that basically means that they exist here and nowhere else in the world. That is the highest rate of endemism per landmass than anywhere else in the entire world. And I think we should flaunt that majorly. And we really need to work to protect these areas. And one of those endemic species is the Iliahi or sandalwood. And we used to have 25% of all of the world's sandalwood. It's also found in India, Australia, and other Pacific islands. But the trees were felled in the early 19th century because they were prized for their fragrant wood in exchange for ships and different supplies. And it was used medicinally, culturally, and economic. And so we actually lost a lot of our sandalwood population. And the ones that are left, most of them are actually endangered. So Santalum haleakala, pictured here, has two varieties, one of which is endangered. And if you do visit Haleakala National Park, you can see some sandalwood if you drive in towards Hosmer's Grove. There's one along the road by that big dip. And then if you do that little bird loop there, right from the kind of campground picnic area, there's a really nice tree on that loop too. And there's another variety of sandalwood, if you ever want people that want to see it, if they do the boardwalk hike that kind of goes around from the Fairmont to the Grand Wailea, there's that trail along the ocean. There's a lot of really nice coastal native plants that people can see there too. The bellflower family is something that's very interesting to look into. This has the highest level of adaptive radiation in plants. So basically you have one colonizer that came over here about 13 million years ago. And from that one colonizer, over 141 different species of plants evolved from that single one, which is a really, really high rate of radiation from a single colonizer, probably due to its relation with the birds. The next plant down from that, I think, was around 90 some. So it really, really radiated quite prolifically. And again, a lot of that has to do with the relationship with our native forest birds, which they still have today, which Laura will talk about a little bit as well. So we want to protect all these different things that I'm talking about because there's a lot of cultural connections with them. So not only were they here before us and they're perfectly suited to live here, but when the Hawaiians came up on the shores, they brought with them their canoe plants, but they found all these great things living here that they used to perpetuate their culture. And so you have things like mamaki, which is native, which is great to creates a great medicinal tea, which you can drink usually at night to help kind of relax the muscles. Lei making, very popular. For instance, maile is native. And then there was a lot of different weapons and cordage and things that were also made from our native species. And if we start to lose these native species, then we're also going to lose these cultural connections. And we saw that a lot with the ohia, the disease that's affecting our ohia tree, and the Merry Monarch. The people were choosing not to go out and collect ohia to adorn the dancers with anymore because of this invasive disease. So for us at the East Maui Watershed Partnership, one of our biggest threats of our native Hawaiian rainforests is feral pigs. They kind of have this ripple effect. They're the primary modifiers. And in the past 30 years, about 50% of our rainforest lands have been degraded or dug up by these feral infestations. And you can really see with the picture here, our first line of defense when we work is to put in a fence. Defense, fence, right? So on the right-hand side, you can see how it's all torn up. That's pig activity. One pig can dig up the area of a football field in a matter of a week. Okay, so they're out there digging up all day long. And guess what? They love to eat that strawberry guava I talked about earlier. And so they basically till up the ground. They act like little gardeners and they till up the ground. They poop out the seeds of the strawberry guava they had earlier that day. And then before you know it, our native forest is replaced by a forest of strawberry guava. So that's just one example. So you put in these fences and you help protect what's still pristine native forest inside of that fence. You keep the animals out. And that's been one of the best ways to kind of help with this problem. So it is the most effective thing we can do. This fence that you see here is in Kaupo Gap. This is actually the fence for Haleakala National Park. You can clearly see what side the animal's on. I think back on this side, it's mostly goats, but they just chew everything down to nothing. You put that fence in and it allows the plants to come back and survive. On average, 1 mile fence costs approximately $230,000 to build. And that's probably even gone up now. There's approximately 100 miles of fence in East Maui working to protect these different management areas. And we ourselves have about 12 miles of fence. The whole idea is that over on East Maui, we still have some pristine forest areas. So we fence it off, okay, keep the animals out. Then we go inside of that fence. We remove the invasive animals inside that fence, mostly pigs, but sometimes goats or deer. And then after you get rid of the animals, we start looking at the invasive plants as well. So things like the strawberry guava, or I'm going to talk to you guys about ginger here, or whatever it may be in that particular area. We start removing that from these pristine areas. And then it's only after that that we could start working on areas that are so degraded that we can actually start doing reforestation and things like that. So here at East Maui Watershed, we're still kind of trying to protect the pristine forests we still have. So if you're driving up Haleakala, and you can kind of see in my picture here, the squiggly road going up. You're going through Haleakala Ranch. You kind of get this long straightaway just before you kind of go through the pine trees and get to the entrance booth to Haleakala National Park. If you're driving up there with guests to go do sunrise or a bike tour or something, look off to the right. You'll see a very large fence that is built. That fence is built to keep out pigs, deer, goats, the whole gamut. And what that fence is part of Haleakala Ranch's Pu'upahu Reserve. So they've taken land out of ranching and fenced it off and trying to create a buffer between the national park and the ranch lands down below. Inside of that fence, they're removing the animals. And then a lot of what we're removing is another plant called gorse. And gorse is an extreme fire hazard. It creates these dense, impenetrable thickets. It regenerates very rapidly. If you ever get around it, it's like very thorny and difficult to work with. So we work really hard to try and remove this gorse plant out of these areas. On average, one plant can produce up to 14 million seeds per acre per year that can persist up into the soil for up to 50 years. And so even if we remove these plants, we have to keep going back because there's that seed bank underground that can keep growing. Another invasive plant we focus on a lot is this Himalayan ginger, which we've like to nickname toilet brush ginger because we don't want, some people call it kahili ginger. It's got a Hawaiian name, and not everything that has a Hawaiian name is native, okay? So we want to kind of remove that, and we want people to know that it's super invasive. It's a big target species for a lot of us, and so we were calling it toilet brush ginger instead. And these plants can create just thickets on the forest floor, and basically they create a rhizome mat. So when you buy ginger at the store and it's kind of like bumpy, that's basically a rhizome. It does that all underneath it, and it will just spread out and grow and grow and grow. And you could cut the plant off and it can regrow from that rhizome again. And so we have to work really hard to remove this plant. It will grow down below, it will grow up high in the nooks of trees everywhere. So we do sweeps to try and get this out of our pristine forest areas. You can see on that top photo there, how that forest there no longer has the layers I talked about. It's got a few trees and it's nothing but ginger underneath it. And that's what happens is as these older forests die off, the canopy might die off. If this is all growing on the forest floor, there's no little keiki seeds to come up and replace that ohia or replace that koa tree. And it's spread by some of our non-native birds as well. And because it's from the Himalayas, it's more of a threat than our other gingers because it can grow at high elevations. And so that makes it one of the bigger threats compared to like other gingers that you might have that don't really tend to spread outside of a lower range area. So that's all I got to say for now. Got natives. I'll take any questions if anybody has. Let me open up my little chat window. Okay. So my first question I see is what organization helps to remove the ungulates? So there's a lot of different organizations out there working to remove ungulates. So the watershed partnerships, the state does it, Haleakala National Park. There's other contractors, the Nature Conservancy. So all of us, depending upon lands that we're managing, usually have a portion of us that are working to remove these ungulates, whatever they may be. And I see a question about ungulates being inoculated with birth control. So that's kind of what we're talking about with the mosquitoes today. But as far as I know, that's a pretty extensive undertaking that would probably cost way too much, because you'd have to find the animals, trap them, and then give them birth control. I don't think that they could spread it to one another, and there's just too many out there. So that's part of the problem with it. So methods to remove the ungulates, there's different methods that are used, mostly just trapping methods, but there's also sometimes in some of our fences, we have these one-way gates, which are kind of neat. So if an animal's trapped inside, they'll go to the fence and walk it and kind of test the fence to get out. And there'll be installation of these one-way gates, or like barrels that are plastic that are angled downward, and they actually find that and get out or slide out and can't get back in. Let's see. Okay. Any other questions? Okay, well, thank you guys for listening then. I believe our next speaker is Laura with Maui Forest Bird Recovery Project. So if anybody else has questions, feel free to ask. We'll take a little break here, go run to the bathroom, get your snack, get your coffee refill, whatever you need to do.
Hey, Allison, I got a question from Adrian Boone, and he's asking if are all East Maui Watershed Partnership lands all fenced to ungulates? I see Haleakala's fence when walking on Hale Mau Trail, but also wondered about
That's a good question. Thank you. So East Maui Watershed Partnership, like I said, is about 100,000 acres. Around 44,000 of that is fenced. So almost half of it is fenced off by us or our partners, including Haleakala National Park. And those areas are all actively being managed. And so that's kind of like we start at the top where it's the most pristine, and then you kind of keep adding on sections here and there and there. So you have like that Haleakala National Park fence that boundaries the crater. It's about 30 miles. And then you'll start getting these fences kind of looping almost off of that, and adding in more and more key sections. And so we go out and do surveys and often look at the forest and the forest health and decide which fences get put in first and where. And we actually, for East Maui Watershed, haven't built fence in a few years. We've been working really intense on invasive species control, but I think we have a fence proposal coming up in the next few years to add on another nice section out in Wailua Nui. So good question though. Okay, so question, wettest place on earth, Green Sword Camp. I honestly don't know if I know where Green Sword Camp is. I'm trying to look, we have our maps, right, with everything. I just know it's Big Bog, and I know that Laura has been there, so she might know the name of the camp itself when she comes on here in a little bit.
Yeah, it's above Hana. It's in the Hana Forest Reserve. But it's pretty high up there. It's, you know, I don't remember the elevation, but it's probably 5,000 feet or so, or maybe a little bit below that.
Do you know where Green Sword Camp is? Have you heard of it? Green
Sword Camp? Oh, okay. Sorry. So I thought you were talking about Big Bog. Green Sword Camp is even higher. Geez, just land. There's a couple Green Sword camps up on the mountain. That's going to be between like 7,000 and 6,000 feet in elevation. It's pretty high up there, and it's pretty wet, pretty boggy.
Nice. All right, well, Laura, if you're ready.
All right. Oh, shoot. All right, are you seeing my screen all right?
I can see it, but I can see your notes as well.
Interesting. What did I share? Let me see. I see, that's what we're looking at. All right, how about that?
Perfect.
All right, cool. Okay, well, good morning, everybody. My name is Laura Berthold. I'm with the Maui Forest Bird Recovery Project. I've been with the organization helping to research and recover these native birds since 2009. So it's been a while. And I'm going to talk to you today about one group of birds that we call the Hawaiian honeycreepers. So to begin with, Maui Forest Bird Recovery Project was established in 1997 by the State of Hawaii Department of Land and Natural Resources, Division of Forestry and Wildlife, and the U.S. Fish and Wildlife Service. Essentially, scientists were seeing that these birds were declining, and they wanted to know why and what management actions needed to occur in order to help recover their populations. So our mission is to develop and implement techniques for the recovery of Maui's endangered bird species and to restore their habitat. So part of what we do is research. So learning more about these native bird species, an estimate of how many there are, what their densities are like across the mountain. We can mist net them and take them out of the nets, do measurements, get samples for disease and diet, and then we put these markers on them, these color bands, and then we can tell individuals apart. And we can follow those individuals over time. We can see how long they live for. We can GPS where they're going and how much area that they're utilizing. We can look at survival rates. We can also find nests and look at productivity and what's affecting their nesting behaviors and their nesting success. So we're learning a lot about their populations, but then we're also performing some of the management that needs to happen, like invasive species control or habitat preservation or restoration, which I'll talk a little bit more about later. So the group of birds that our organization works with are called the Hawaiian honeycreepers. A lot of times they're called forest birds because they live up in the forest. Another term that you may hear is Hawaiian finches. And that's because their ancestor was a finch that likely came over from Europe or Asia over 5 million years ago. And over millions of years, that one species adapted and evolved into over 50 different Hawaiian honeycreeper species. So this is, Allison was talking about adaptive radiation earlier. It's the diversification of a species into new forms that each adapt to occupy a different ecological niche or role through the forces of natural selection. So this chart here kind of shows how these birds kind of overtook these certain sectors of the forest with their food resources. So you have your nectivores, and some of these birds have curved bills, like the curved flowers that they're drinking nectar from. Some of them are helping to pollinate those plants. Some have really strong bills, like their ancestral finch that crack open seeds and fruits and nuts, and some of them help to disperse those in the forest, helping in the regeneration of it. Generalists will eat a little bit of everything. Foragers among the leaves and bark pickers are typically going after your invertebrates like snails, spiders, and insects, and they all have really unique bills as well. This bird right here, the Kiapula'au, which is found on the Big Island, is sometimes called the woodpecker of Hawaii. It has this lower bill that kind of acts like a woodpecker would, digging into the bark, and the upper hooked bill acts kind of like a fishing hook and gets those caterpillars out of those holes in the bark. So Each one of these is unique and they are endemic to Hawaii, so found only here. If you're interested in learning more about the Hawaiian honeycreeper evolution and how the islands kind of evolved and how the bird species evolved with those islands, there's a great picto chart, and we'll be sending this link in our resources email after the training. Hawaiian honeycreepers are not only important to the Hawaiian ecosystem, they're also important to people. Today, bird watching is one of the most popular activities that people do. So you're going to get a lot of people coming here to the islands to go look for the birds. So they enjoy watching them, listening, lots of photographers. And then they're also important to Hawaiian culture. In ancient Hawaii, there were special bird catchers that would go up to the mountain, catch the birds, pluck their feathers, and those feathers would then be used to create these amazing cloaks and capes and mahiole or helmets that the ali'i would wear into battle. And it was said that there was a lot of mana or power associated with those feathers and those cloaks, and they would protect those who wore it. Today, we still have mele, oli, and hula that are revolved around the birds. This picture is from the 2010 naming ceremony of the kiwi Q, the Maui parrotbill, which lost its Hawaiian name because it was so rare. But the Hawaiian Lexicon Committee, the keepers of the Hawaiian language, bestowed upon it a new name, and there was a wonderful naming ceremony, which again I'll have a link to that in our after email. Another link I'll provide with you guys is this great presentation by Noah Gomes. It's on the Hawaii Volcanoes National Park website about the Hawaiian bird catchers. He did his graduate research on them, so it's a really great resource to have. So, who are Maui's Hawaiian honeycreepers? We have 6 species here on Maui. There are other Hawaiian honeycreeper species found on the other islands within Hawaii. So there are more than just 6 species left. But I'm going to go through briefly each one of these and introduce you to them. So first we have the apapane. Apapane is considered the most abundant Hawaiian honeycreeper species because it's found across the main Hawaiian islands and found in kind of different microhabitats as well as they are usually nectar feeders. So you'll find them up on the tops of ohia trees and some of the other subcanopy trees as well. You can tell them apart from the other red birds because they have white underneath their tails and a short black bill. So I always say the way to remember them is apapane wear white panties, so apapanties. They are the background music of the native forests. They're kind of constantly singing. When I'm teaching new people the sounds of the birds in the forest, they're constantly asking, what's that sound? What's that sound? Who's that bird? I'm like, that's apapane, that's apapane, that's apapane. They have so many different varieties and kind of dialects that they have on the mountain. So here's a listen for them. Next, we have the Hawaii amakihi. There are other amakihi species found in different islands within Hawaii, such as the Oahu amakihi, but this amakihi is found on Maui, Molokai, and the Big Island. They have a slight curve to their bill, and there's this kind of black in between the bill and the eye, and then there's this green, awesome green color, vibrant green color that they have. These guys are generalists, so they'll drink nectar, eat fruits, insects, and spiders. So here's ohia. This is akala, the Hawaiian raspberry. That's a popular plant for these birds. These guys, as well as apapane, are being detected at lower elevations. So most of the bird species I'm going to be talking about today are found above 4,000 feet in elevation. But Hawaii amakihi I've seen as low as 500 feet along the Hana Highway. Apapane as low as 1,000 feet on the Waihe'e Ridge Trail. So they could be evolving some resistance to avian malaria or disease that's spread by mosquitoes, which we'll be talking about a little bit later. So this is definitely a sound that you want to become familiar with, because a lot of times along the Hana Highway, I'll get out next to a gulch and I'll just hear an amakihi. They're really hard to see because they're just flying around really high. So all of these sounds are available on the MauiForestBirds.org website, and then we also have some videos on our YouTube channel too. Next, we have the EEV, which is a popular one to see. They have that beautiful red color, black wings, black tail. They do not wear white panties. And then they have that beautiful orange curved bill. And so Allison talked earlier about the Hawaiian lobelia or the bellflowers. And so that curved bill and those curved flowers kind of match up perfectly. He's a juvenile right here. They're gonna start off this like awkward greenish color and get that nice red color as they get their adult feathers in. A few years ago, these guys were listed under the Endangered Species Act as threatened, and that's because many of their populations across the islands are declining because of disease. They have a pretty unique call. They a lot of people say, oh, they sound like a R2D2 or robotic, kind of squeaky, rusty sound to them. So the first three species I talked about are found on multiple islands within Hawaii. The next three are endemic to Maui, so only found on the island of Maui. So Maui alawahio, or Maui creeper, named because it creeps along branches looking for bugs to eat, is a pretty unique species within the Hawaiian honey creepers. They're typically in family groups, so you have a pair and then the offspring from last year sticks around to help raise the offspring from this year. So it's called cooperative breeding. So they're pretty curious. They'll come down, the whole group of them, they'll come check you out in the forest. They'll do their little chips. They're interacting a lot with each other, doing acrobatic flips to try to get those little caterpillars along the branches. The young ones are kind of a grayish green and they get that yellow color as they age. These guys used to be found all over Maui and Lanai and now are only found on East Maui, but they are found in both native and non-native forests, such as up at Poli Poli. So they might be adapting to some sort of insect that's found there. The first part of this sound clip is a song, but most of the time you're just going to be hearing them make the chipping noises that come after that. Next, we have the aukohekohe, or the crested honey creeper. It's named because of that crest on its head, which likely helps to pollinate the blossoms, especially the ohia blossoms. These guys are a little bit bigger than the rest of the birds, so a lot of times you'll see them chasing away iwi and apopane from those ohia blossoms because they're pretty territorial. This is a young bird right here. They are considered endangered. There's less than 2,000 of them left. They used to be found all over Maui and Molokai and now are only found on a small sliver of slope on the windward side of Haleakala. They have a pretty unique call. You can't really mistake them, and they kind of sound like a frog. It also kind of sounds like ah kohe kohe. Last but not least is the kiwikiu, or the Maui parrotbill. It's named after its parrot-like bill, but it is a Hawaiian honeycreeper. It uses this really strong bill to pry open branches and twigs and fruit to get at the insect larvae inside, so mostly looking for caterpillars of moths and beetles. The young are dependent on the parents for up to a year, and that's because these guys are considered a specialist. So they're using that bill in a unique way to get certain insects. So the young one has to learn that from the parents. So they are endangered. There's only about 200 of these guys left. And like the akohe-kohe, they used to be found all over Maui and Molokai, and now are only found on a small sliver of slope on the windward side of East Maui. The first part of this sound is the male song, and then otherwise you're just going to hear these kind of chips and whistles from these guys. So this is going to be a video of a male kiwikiu, and you'll notice he's got color bands on. So those color bands are unique to this individual. We know that he was banded when he was in his 2nd year of life, and that's because there's different ways that their feathers look like when they're young versus when they're old. The males are a little bit brighter than the females. They have a little bit bigger of a bill, and you can see him using his bill here. And yeah, this was taken in the Nature Conservancy's Waikamai Preserve, one of the last areas that these birds can be found in. You can see they have tiny little tails, and there he goes. These are just some of the places that you can find the Hawaiian honeycreepers on the island of Maui. The easiest places that you can see them is up in Kula Forest Reserve or Poli Poli. You can kind of drive right up to the campground at Poli Poli and pretty much see all 4 of these species here. Hosmer Grove within Haleakala National Park is another easy place to find at least 4 of the birds. In order to see akohe-kohe and kiwikiu, you'd have to go on a hike with the Nature Conservancy into Waikamai Preserve, which they used to do monthly, but because of COVID, those are on hold as of right now. So your endangered birds are pretty much going to go from Waikamai all the way over through the national park in Kipahulu Valley to Mana Wainui over here. So this kind of slight little ring between about 5,000 feet and 7,000 feet, so not very much area that you can actually see these birds. Over on West Maui, you're really only going to see Apapane and Amakihi. We have the Waihe'e Ridge Trail, the Arboretum, Kapalua trails up here, where you get a chance to see those too. There are EEVs still on West Maui, but they're really hard to find. They're way up high in some of these valleys up on the top of West Maui. So as I mentioned earlier, we had over 50 different Hawaiian honeycreeper species, and now we have only about 17 of those species left. So we've got a lot of extinct birds, and then those that are left are typically endangered or threatened, and they face a lot of threats. Allison talked a lot about the habitat loss and degradation from wild ungulates, and then we're going to hear from Lissa about some more invasive species like disease and insects that can affect our native forests. And then we also have introduced mammalian predators. So these birds evolved with no mammalian predators on the island, and humans introduced them. We have mongooses, cats, and rats, all that are pretty good at climbing trees and getting at these nests and eating the nestlings and eggs and even the adults on the nests. And then we also have introduced disease that are spread by introduced mosquitoes. So we have several introduced mosquito species, and some of them can spread disease from human to human, and others can spread disease from bird to bird. And climate change is obviously having an effect on all of this. To kind of go more into the disease aspect, and Taya is going to also be going into this more, I've got this little kind of graph for you guys. So we used to have different types of native forest or habitats from Mauka to Makai. There was always naturally a tree line where the trees didn't go any further. You know, for instance, on the top of Haleakala, it gets to be more shrubland. And on West Maui, it gets to be more of a boggy area. And, you know, over time, we had different introductions of different plant species, and now we have non-native forest or mixed non-native and native forest, just different kind of habitats. And most of our native bird species are going to be dependent on those native plants. And then we also had introductions of mosquitoes, and most of these mosquitoes were found lower in elevation, so typically below 3,000 feet or so. And that was because we had year-round warm temperatures, lots of standing pools of warm water for the mosquitoes to breathe in, just this fantastic habitat for these mosquito species. But because of warming temperatures, these colder high elevation areas are now having mosquitoes. And sometimes it might be, you know, seasonally that these mosquitoes get all the way up to the tree line, or the disease gets all the way up to the tree line. But we're learning more and more about this, and how, you know, how often mosquitoes are going up there, and how much prevalence in the disease there is at these higher elevations. So in terms of our native honey creepers, Apapane and Amakihi, like I mentioned earlier, you can see them at pretty low elevations. Then they go all the way up to even above the tree line. They're in the shrubland habitat as well, and the bog habitat. So they're pretty prolific. They're a pretty abundant species, both of them. And that's likely why they are able to withstand mosquitoes and disease at these lower elevations. You're really not going to get Eevee or Alawahio until about 4,500 feet in elevation, and they'll go all the way up to the tree line as well. And you won't get the two endangered, Kohe or Kiwikiu, until about 5,500 feet. So not very much area for these two endangereds, and even Eevee and Alawahio, to survive where there's low levels of disease or no levels of disease. And mosquitoes are really kind of pushing the limits of where these birds can live. So what can we do about disease? Well, there's a couple of kind of options. We've got disease control and habitat restoration. So this question's asked a lot. Can we treat or vaccinate the mosquitoes or the birds? There isn't a way to do that, and even if there was, it would be very difficult to catch every single bird or every single mosquito to treat them or vaccinate them, and that vaccine process wouldn't actually correspond to their young. So you'd still have to keep doing it over time. So that's not the path that we're going. The pathway that we are going is to develop a control method to decrease the mosquito populations which would then in turn decrease disease and hopefully increase the area that these birds can be found. And so I have a video talking to that's going to kind of show you what this control method does. It's kind of like a birth control, and we'll watch that next. But it's going to take a few years for this to develop. You know, there's all the lab process and the trials and the permits, and I think Tay is going to get into that more a little bit later. For now, it's important to limit mosquito breeding and to create and maintain disease-free habitats. So mosquitoes depend on standing pools of water. So, personally, we can get rid of buckets with water in it, or tires, or clean out our gutters. That'll help prevent mosquitoes from breeding. And we can also have the best habitat available for these birds. So putting up the fences, getting the ungulates out, because the ungulates can create areas where mosquitoes will breed and survive. And then also planting and reforesting habitats. So here's the video. Take a quick break from me talking and listen to this nice 2 or 3 minute video about mosquito control, but it's going to take a moment for it to load.
Besides setting up mosquito traps and treating mosquito pools with BTI, there is an alternative option for large-scale mosquito control. And it's a bacteria, Wolbachia. This naturally occurring bacteria lives in symbiosis with many insect species, including Culex mosquitoes in Hawaii. Hawaii has several different strains of Wolbachia, and different strains are incompatible with one another. Meaning, if a male mosquito mates with a female with a different strain of Wolbachia, the resulting eggs will not be fertilized. Therefore, if lab-bred male Culex mosquitoes, which don't bite, were given a strain of Wolbachia, then were released into the wild and bred with wild females with a different strain of Wolbachia, no offspring would be produced, and the mosquito population would be significantly reduced within 1 generation. This phenomenon is already being implemented in Florida and California to help prevent the spread of other mosquito-transmitted diseases. Also, Wolbachia can only survive in insects and cannot transfer to other animals. Currently, the University of Hawaii and Department of Land and Natural Resources are researching this future opportunity, but will first need full government and public support.
So you can view the entire documentary on YouTube. And this is a nice little clip from Kauai Forest Bird Recovery Project, who is our sister organization on Kauai. And hopefully this mosquito control technique will be available in the next 3 to 5 years. And kind of to emphasize the importance of this control, I've got another little graphic for you. So most of our, at least the 3 Maui endemic species are found on the windward slope of Haleakala over here. And we've got 2 species over on the leeward side, over on this side of the island. And we've got 3 species over on West Maui. And likely the reason why we have 6 species over here on the windward side is because this is the best area for the birds in terms of disease and habitat. So low levels of disease, likely very few mosquito populations. But if we can get mosquito control and get mosquitoes, out of these kind of mid elevations or even the high elevations, and also, create more forest habitat for these birds, we can then maybe see these species in other places that they used to be found, such as the leeward side of Haleakala and on West Maui. So we are outplanting on the leeward side of Haleakala. We, as well as the Department of Land and Natural Resources, Division of Forestry and Wildlife, and Leeward Haleakala Watershed Restoration Partnership, and a number of other organizations have been planting on this side to try to bring back the native forest here. There used to be contiguous forest. A lot of people go on that side of the island as they're coming back from Hana and they think it's so desolate. But there used to be native habitat there, but there's been over 100 years of feral animal grazing, and it's pretty much become an area with a lot of grass and these erosion scars from the lack of trees and from ungulates being on the landscape. So these high elevation areas, this is 5,000 feet, have some remnant forest left. You can see these kind of patches here. These are big trees. These are ohia and koa. And so as you're driving along the Hana Highway, here are the windmills. You can kind of actually see from the highway, not the Hana Highway, but this is the Piilani Highway. And you can see this kind of strip of green up top, higher in elevation. And it's been growing the past few years. So these are just these tiny little outplantings here. And hopefully one day we can have contiguous forest connecting these gulches that have remnant forest in it. And this will be great, not only for the birds, but for the restoration of a watershed, a restoration of an ahupua'a. It's protecting the high elevation forest. It's replenishing the aquifers and the streams. it's preventing erosion, it's preventing that soil from getting down into the reefs, into the fish populations. When you do come from along that side and it's been raining, there's a lot of soil that ends up into the ocean. So without planting and kind of creating erosion control barriers, we can help prevent that from happening. And that's nearing the end of my presentation. I talked to you today about the native Hawaiian honeycreepers, which is one group of birds that are found here in the Hawaiian Islands. We have multiple types of native birds. We've got nene, our Hawaiian goose, pueo, our native owl. We've got tons of different types of shorebirds and seabirds and water birds that we just didn't have time to talk to today, and I don't necessarily have the expertise in them either. But that's why we have guest speakers. So we've had a seabird talk before, and so hopefully we can have more presentations about some of these other bird species in the future. We also have a whole pile of non-native birds that people always ask me questions about too, and I'm sure you also get questions from guests as well. I recommend picking up a guidebook, like a Hawaii Audubon Society guidebook. There's also an app called the Merlin app, and it's a great investment. It has all the bird calls on it, and it can help you identify species. So that is the end of my presentation. And let's try to jump back on and see if there are any questions. Any questions? So I can't remember which one. It was the Apapani. So what disease was showing on the Apapani picture? So there's two diseases that are spread by mosquitoes. There's avian malaria. Avian is another word for bird. And then there's also avian pox. So the pox, you can kind of easily see when a bird is infected with it. Sometimes they'll have these like kind of little, kind of like pimply looking things on their bills or on their eye, on their feet. Sometimes this can cause them to lose a limb or lose an eye or lose a foot. And so that in turn will make them more susceptible to malnutrition or getting eaten by a predator. Yeah, so it was probably the pox. How is the kiwi-kiwi doing? How many are left? So kiwi-kiwi is the most endangered Hawaiian honeycreeper on Maui. There's less than 300 of them left. I think our 2017 estimate was 157, but there's always kind of error margins with that. They are pretty rare. They are kind of, looking at modeling and stuff, we're potentially seeing them become extinct in the next 10 years. And so that's why, getting mosquito control out on the landscape is really, needed. And otherwise we're going to see more species go extinct. We have found individuals of kiwi-kiwi at 7,000 feet that had malaria. So it's no longer this thing that happens just below a certain elevation. It's across the mountain. So sorry, it's not a happier story. We still see individuals, and there's still, some out there. It's just there's not very many of them. Is there advertising to encourage tire recycling and reduction of the pools of water in trash? I live up on Olinda Road, very close to my bird and the small farms properties here. I have a lot of trash and tires. I remember we worked with the Department of Health a few years ago when there was the scare with dengue, and they really were doing a push with people to get to recycle their tires and to get the buckets and wheelbarrows and stuff over. Really, a lot of these things kind of depend on the human need rather than the bird need. So I haven't seen that recently, the advertising, but I could be wrong. Thanks, Serena. Malama Maui Nui is a great organization that does take recycle tires. They do ask for a donation though, because it does cost them money to recycle those tires. What's being done to prevent Rod from coming to Maui? I am going to wait for Alyssa to answer that question because she's going to talk about Rod in the next presentation. Are there plans to maintain a new population of captive kiwikiu? So I think the short answer is yes. There are plans that are being developed right now, permitting being looked into, the kind of plan of how it's all going to work to create a few new captive breeding, or at least captive holding populations of kiwikiu at a few different facilities on the mainland who specialize in this type of captive breeding and raising and rearing. What are the plans for the site on the backside of Haleakala since mosquitoes affected introduction of kiwikiu there? So for the backside of Haleakala, there's still going to be restoration going on there because it's important for native plants, insects, spiders, snails, and the birds in the future. We've been planting out there since 2013. In 2019, we actually sighted or heard an EEV out there. So hopefully one day EEV and Alawahia will make it there on their own once the forest kind of returns a little bit more. Mosquitoes are not only threatening the leeward side of Haleakala, they are threatening the windward side. We have been going out to different locations on the windward side of Haleakala, like various elevations, and catching mosquitoes and catching birds to look at the different disease levels across the different elevations. So hopefully, I mean, in the future for the leeward side, you know, once we get mosquito control out onto the landscape, it's going to first be on the windward side because that's where our two endangered species are. But hopefully it would happen also on the leeward side down the line and would be habitat for these birds to go to in the future. But that's probably not going to happen in the next few years. There's a lot of questions. Oh, thanks, Allison. Maui County has a hazardous recycling event coming up on March 7th. Maybe I will make an appointment too, because I have some stuff. So the captive breeding, there's another captive breeding question. So currently there is not a captive breeding population. There used to be up until 2019, but we're hoping to create a new few captive populations on the mainland at a couple different facilities to try out some new methods of having these birds in captivity. There's another Maui tire recycling comment in the comments. So recycleinhawaii.com. Yeah, I feel you, Catherine. I have a hard time dealing with my landlord and getting him to do things that are environmentally savvy. But hopefully, you know, maybe with this this recycling event that's coming up on Maui, maybe that's an easier way to do it. Like, I don't know if you have to pay to recycle the tires or not, but maybe. Yes, with art, if there are only 200 kiwikiu left, doesn't pretty drastic action need to be taken? That is correct, and that's why bringing them in captivity is one of the actions that's going to be happening, because if we wait until mosquito control is ready to be put onto the landscape, we likely won't have kiwikiu left. So at least bringing some pairs and individuals into captivity, we would have kiwikiu for the future to be released when mosquito control does happen. So, I mean, it's not, bringing birds into captivity is not an easy thing to do. There's some steps that need to be done, permissions and permits and a plan. And that's kind of been being worked out since 2019. And obviously COVID hasn't sped things up. So we just got all the permission, well, at least partial permission. And hopefully by spring 2022, we'll have the first individuals being captured. So there's a last question because we've got to move on to Alyssa. Do you maintain any other captive populations at your Olinda facility? So Maui Forest Bird Recovery Project does not maintain captive bird populations. Our Olinda office is just an office. We do all of our work out into the wild in wild areas, but Maui Bird Conservation Center, which is right next door to us, they're run by the San Diego Zoo. And they used to have a captive population of kiwikiu. I think there's only just a couple individuals left there. And because they have several other species that they're trying to breed in captivity, there's just not enough room for kiwikiu there anymore. They've brought in a couple more species from Kauai that they're trying to focus on because those birds are also in pretty devastating numbers. And they also work on alala, as well as a few others. So it's just, you know, we have so many endangered species like Serena was talking about and very little resources and funding. So the focus has been on other species at that facility right now. All right, well, if we have more time at the end, I'm happy to answer more questions. Is Lissa on, or is she still having computer problems? Okay, thank you, everybody.
Okay. All right, can everybody hear me? And see the correct presentation?
Yep.
Looks good, Lissa.
Thank you. So sorry about that. My computer decided it would crash a few minutes ago. So it's like crossing my fingers over here. So again, my name is Lissa Strohacker and I work with the Maui Invasive Species Committee. And so I'm going to talk just a little bit about the work that MISC does in invasive species in general, the threats to the islands, and what you can do to help mitigate both the impacts and the threats. So the Maui Invasive Species Committee was formed in the late 90s to fill the gap. We respond to some of the high threat invasive species that have reached the islands but have not yet become widespread. We have 3 field crews. They work on plants, coqui frogs and other vertebrates, and little fire ants. There are invasive species committees throughout Hawaii. Each committee works on high priority pests on their own island. So, you know, like if you're familiar with Hawaiian native species, there's different species present on each island. Same thing with some of the invasive species. So, you know, there's certain things that can be contained within one county, but yet are widespread elsewhere. So each ISC is unique. And yeah, we depend on partnerships quite a bit to get our work done. So we all deal with invasive species to one degree or another. It's just part of life in Hawaii. If it's termites in your home or ants in your sugar or rats and mice in your fruit trees, there's always some aspect to invasive species, you know, just sort of day to day. But invasive species are more than just a pest or a nuisance. There are some things that we can do to really address the problem. Invasive species, of course, they impact the survival of native species, as we've learned through the other presentations. They affect watershed function. Strawberry guava reduces the capacity of watersheds. Our cultural connection to the land. So for example, rapid ohia death keeps halau out of the native forest. They can't go in. They've put a kapu on harvesting from ohia that they used to, predominantly harvest from. Little fire ants rain down on beachgoers, hikers, even surfers. It affects our lifestyle. They also jeopardize our agricultural sustainability as we're looking towards, more food independence. The presence of some of these invasive species increases the costs of growing these things to the point that it becomes prohibitive. On our lifestyle, one of the things that's amazing about Hawaii is that it's mostly the perfect climate all year round. There's no central heating or central air conditioning or anything like that. That's in part why people travel to Hawaii. It's really paradise. And having these pest species outside affects that. It affects tourism as well. Invasive species also affect resilience against the impacts from climate change. So a healthy, intact native forest is less likely to be damaged from hurricanes. So we saw that with Hurricane Azelle when it hit, or Tropical Storm Azelle, when it hit Hawaii Island. A lot of the damage was caused by the breaking of branches from invasive albizia trees. Invasive grasses fuel wildfires, more so than would happen in a native-dominated ecosystem. Invasive species have a long history in Hawaii. Essentially, as soon as people started coming to the islands, we started introducing plants and animals. Polynesian rats were the first invasive species to arrive. They showed up about 400 AD. And as more people came and travel became easier, more of these species came. So we got different rat species arrived, the black rat, the Norway rat. With the 1780s, with whaling and plantation life, sugarcane, pineapple, the rate of introduction of new species went through the roof. One of the biggest challenges that early colonists faced was trying to get honeybees to Hawaii. So it took several trips. They were trying to ship them around this was of course before the Panama Canal. So they tried to ship them across the United States and get them to Hawaii, and the ice would melt, they would get too hot, or they would freeze, or they would die. Now, with all of these advents in technology and global travel, we worry about the threat of Africanized honeybees. So each new wave of industry has brought a new a new threat, I guess, to Hawaii, a new wave of these invasive species arriving, as well as new technology has increased the likelihood of these species arriving. Invasive species brought to Hawaii have changed the forest. Most of the forest around low elevation is non-native plants. So some of these plants and some of these animals were brought here intentionally, of course. This on the left side is Myconia. This is brought as an ornamental plant in the 1960s, and then it escaped cultivation and threatens a huge watershed threat out on East Maui and Hana. Himalayan ginger, again, Allison has talked about that one. It was introduced intentionally. Some of these plants or some of these animals, like the Vespula wasp, hitchhiked here on commodities. So Vespula likely arrived in Christmas trees imported in the 1940s. So that's one of the reasons that there's so much inspection that goes on Christmas trees. If you were to make a list of all the plants that were naturalized, self-sustaining wild populations in Hawaii, just a straight list of the number of species, 46% of those plants would be introduced, or would be introduced plants. Sorry, did that skip back? Okay. The number of plants that have been now introduced to Hawaii is 10 times the number of native plants. So this 46% is just the number that are naturalized. These are the ones you see growing on the roadsides. But if you looked at the total number of plants introduced, it would be phenomenally high. It's, there's 12 to 13,000 non-native plants present in Hawaii today. They dominate 75% of our island. It's really about 200 species or so that dominate the 75% of the island. Again, this is our current canoe. According to the Hawaiian Biological Survey, about 120 new species become established in the state each year. This rate of introduction is so high in part because we're in the middle of Pacific shipping routes. We have a variety of climate types and habitats. And that, not only do people find them suitable, but some of these pest species find them suitable. There's also fewer predators here for these pest species when they arrive. So they become new pests. So if you think about that, 120 new species, that's a new species on average every 3 days. This happens day in, day out throughout the course of the year, which sounds overwhelming. The good news to a certain extent is that not all non-native species are invasive. So there's a statistical rule that estimates that about every 1,000 species introduced, 100 escape cultivation. Of that original 1,000, 10 will become naturalized and firmly established. So that's that 46%. Those are the naturalized widespread species that are present throughout the state or in our islands. This is an example. This is the sleepy orange butterfly. It first showed up in about 2014. It was first identified and documented on Maui, but it's statewide. And it's present. It's not, the caterpillar isn't poisonous. It's not, voracious eater of anything. It's here, it's not going anywhere. It probably hitchhiked in landscape material or equipment or something being shipped to Hawaii. But it's, again, not invasive because it doesn't cause harm. But 1 out of that 1,000 species will become invasive and cause some sort of harm. But there's a time, of course, when we can address the problems. This is a species area curve. It's often used to communicate invasive species issues and management issues. So, of course, the best, the area infested is on this axis. So, the longer a species is here, the more widespread it will be. And then, of course, the cost of controlling these species goes up as they become more widespread. So the most efficient way to stop pests from getting, or the most efficient way, to deal with pests is to stop them from getting here in the first place. Generally, after these species have arrived, there's a lag phase in which they can be effectively contained and eradicated. So this is where MISC is working to a certain degree. It's this early detection, rapid response. Oftentimes, once they've been here for, they reach a certain population threshold, a tipping point, the population increases dramatically and quickly until they become widespread. A lot of times people become aware of their presence after it's actually they're too widespread or too expensive to contain and control. When prevention is one end of the spectrum, the other side is, boundary control. So working within, species within your yard or within your management area, or addressing species through biological control. So that's reducing the impacts through the careful introduction of a natural enemy. MISC is of course, not the only organization that deals with invasive species issues. Hawaii Department of Agriculture at one end works basically at both ends. They work a lot at the prevention side, rapid response, as well as the research that goes into introducing biological controls. There's the Mamalu Poi Poi, which is an early detection program that looks for pest species at the airport. Our partners at Division of Aquatic Resources, National Park Service, Fish and Wildlife Service, the watershed partnerships. So everyone deals with it to some degree. And there are plans. So there's a lot of effort and strategy that goes into addressing invasive species in Hawaii. So there's a biosecurity plan, the Hawaii Interagency Biosecurity Plan. And this identifies some gaps in funding, some gaps in communications. And so it's lined out on it's about a multi-year plan, and you can check in on the status. So sometimes, if you're concerned about invasive species ahead of the legislative season, you can check in to see where the biosecurity plan is and what bills are being put forth. You can follow the progress of those, because really the single most important step is to improve biosecurity in the Hawaiian Islands if we're able to deal with this. Also, but part of biosecurity is biological control. So we always bring this up because biological control is not the mongoose. So the mongoose never was a researched natural enemy. It was introduced in the 1880s, kind of by an independent sugarcane planter. And even at the time, people didn't think it was a good idea, that there were no regulations, no restrictions on bringing these things in. Classical biological control is the well-researched introduction of pests or species that are dependent on the pest. So this, for example, is the golden Myconia butterfly. And it's from the same host range, from the same range as Myconia. And these caterpillars, the only thing they recognize as food is Myconia. They don't even see anything else as food. So if they run out of food, their population declines. And what they do is they eat up these gigantic leaves of Myconia, put holes in it, and reduce the impacts because they open up light gaps so other species can grow underneath. They hatch out as pretty yellow butterflies. So it's a pretty attractive biocontrol. This is one, of course, that's still in the works right now. It's very promising, but it has yet to be released in Hawaii. And so MISC, we work on rapid response and containment. So pest prevention, but before these pests are widespread. These are some of the pest species that we work on: veiled chameleon, ivy gourd, coqui frogs, little fire ant, Myconia, and then these grasses at the bottom are fountain grass and pampas grass. We work on some 40 other species, but we'll keep it simple and work on them. I'll highlight the main ones that we work on. Our species, the target species that we work on, are selected based on the threat, based on a combination of the threat. So this is an example of one of these species that's high threat. This is a veiled chameleon. It is similar to the Jacksons in its behavior. It's a tree-dwelling, slow-moving chameleon. It moves the same, but it has this shark fin on its head. It was introduced in the pet trade, smuggled in illegally, and then it escaped captivity. One of the concerns about this is that it was a super high threat because it lives up to 9,000 foot in elevation. And in captivity, they feed it baby mice. So there was worry that it could get up into the native forest and eat our native forest birds, similar to what a brown tree snake would do. When it was found, though, it was only in one neighborhood in Makawao. So a high threat species, not yet widespread, it became one of MISC's target species, and our crews went out every 6 weeks until we could not find any more. Then we did public relations, newsletter blasts, and papered the neighborhood and looked again and again and again. And it's possible that it's been eradicated. We have yet to find it. And that would be the first eradication of an invasive reptile from an island ecosystem. So it's possible to get rid of these things if we find them early, and that's where help from the community is essential. Most of our reports of these species, some of these depends, but for example, little fire ants, 11 of the 17 known populations have been reported by the community. So I'm going to highlight a few of the species that it's helpful to have you report. Coqui frog is one of those. These are, of course, Hawaii has no native amphibians. So coqui frogs have been introduced accidentally from Puerto Rico. They reach amazing density. It's about 22,000 frogs per acre. That's 2 to 3 times greater than in their native Puerto Rico. And of course, they're known for their call. So we'll see if this works. I didn't get a chance to test it again after my computer crashed. Otherwise, you'll have to listen. So they are saying, coqui, coqui. And you can imagine with 22,000 frogs per acre, it's pretty deafening. In certain areas and gulches, they echo off of the gulch rim. It completely changes what it sounds like in Hawaii. People don't sleep with their windows open anymore. They run their air conditioners at night or keep their windows shut so that they can sleep at night. But also, coqui frogs tend to shift the balance towards more non-native species. So they have this huge input of nitrogen that produces, from their poop. It's a huge input of nitrogen that then fertilizes the soil and encourages the growth of non-native plants like strawberry guava. They also provide a food resource for mongoose in particular. There tend to be less rats present where coqui frogs are present, but that might be because there's more mongoose. But that could have a great impact on our ground nesting birds. Coqui frogs on Maui are mainly in the Haiku area. The core infestation is along Maliko Gulch. but then they're spreading somewhat eastward. We are working to contain them. It's sort of like firefighting techniques. You work from the outside in. And again, it's firefighting techniques in that we use a solution of 16% citric acid and water mixed together and then sprayed out with fire hoses. So we've thoroughly drenched the area. The citric acid is used because it breaks down really quickly, especially as soon as the sunshine hits it. It really only is active for about 30 minutes. And it can be a skin irritant, and certain plants don't like it. They can get a little bit burned and leaf drop, but otherwise it doesn't seem to have any, long-term impacts. Again, it's, active for about 30 minutes and then breaks down quickly. Insects aren't bothered by it. It's only other soft-bodied invertebrates like worms, which should be underground. We install a network of PVC pipe through some of these deep gulches. You can see here on the left, the crew out there installing that, and then they go out and they'll work in the evenings, spraying when the frogs are active to make the most of it, the most use of it. We've had a lot of help from our community as well. We started a community koki control program where we give neighbors supplies and training, and they work together in their neighborhood. They'll have spray nights every 6 weeks, and they've really reduced the density. So it means it's a win for both of us, for all of us, in that they're sleeping better, they're controlling their frogs, and there's less vectoring of these invasive frogs from properties when people go, to dinner and things like that, as they drive around, because koki are notoriously good at hitchhiking on cars, vehicles, recycling, etc. There are other frog species on Hawaii. The one most often confused with the koki frog is the greenhouse frog. So 2 of the 3 frogs in this picture are koki frogs. The koki have large toe pads and a relatively broad snout. So this is a female koki, in the middle is a male koki, and then on the right side is a greenhouse frog. Greenhouse frogs are mottled, they have more claw-like toe pads. And most importantly, the easiest way to tell the difference is, of course, the noise. Greenhouse frogs sound a little bit like crickets. Koki frogs say koki, koki, from around dusk until the middle of the night, and sometimes you'll hear them early in the morning. And again, community reports have been essential in dealing with this species. A lot of times we depend on the community to find these small outlying populations where we don't necessarily know where they are. We've captured koki pretty much everywhere on the island where people are. And so thanks to these reports, we've kept them from becoming widespread. And then the next species I'll talk about is little fire ants. Little fire ants are unusually small. They're stinging ants. There are no native ants in Hawaii. So we have these introduced ants that form super colonies, and they compete from the ground. Or they form these super colonies that form a network between the ground and up into the trees. And they outcompete all other insects present. There's a 90% decline in insect biodiversity in New Caledonia where they've invaded. And in sections of Tahiti, people have gotten so frustrated with trying to deal with these invasive ants and getting stung over and over that they just abandon their land. Pets become blinded by these stings. The animals, the insects will get near their eyes, encounters with animals become inevitable, and then the animals get stung. There's on Big Island right now, there's certain valleys and whatnot where people no longer hike because they have these stinging ants raining down on top of them. So what we do to control them, let's see, let me get to the next slide here, is we use a bait that gets to the queen. So one of the challenges is that there's so many queens in a colony that the bait is, you have to get rid of the queen to get rid of the colony. Okay, so yeah, it looks like there's some issues with my slides, so I'll try to slow down and make sure everything matches up. Okay, so one of the challenges, yeah?
You're good. I think
Okay.
She may have had a lag on her end. But
Okay,
you're good.
sounds good. Okay, thanks. Just a minute, please. Okay, so one of the challenges is that we have a really large infestation of little fire ants in Nihiku. Nihiku is the densest, wettest jungle. It's perfect habitat for them, but extremely challenging for people to work in. So what we have done to control it is, or what we're trying to do to contain that infestation, is that we are working using helicopters, mixing the bait this insect growth regulator, which is essentially ant birth control. And then we spray it out using helicopters in a very systematic pattern. That's the GPS unit showing the tracks, the helicopter tracks. And it's reducing ant density, so it's effective. Again, it's much easier to deal with smaller infestations. Of all of the 17 infestations that we've found throughout Maui County, we have the Nihiku infestation and 2 others that are in active management because we've been able to reduce the density throughout the rest of, and hopefully eradicate these populations. They're on track. Okay, let's go to the next slide. Again, there are 60 some species of ants throughout Hawaii. They are all introduced, but not all ants are fire ants, not all ants are little. So this is some of the examples of ant species that are present throughout Hawaii that are often confused. These are the ones that are common in people's backyards. There's little fire ants, of course, are the smallest. So they're all one color. And essentially, the easiest way to tell is to collect a sample and send them to us. So there's resources and information on our website, as well as stoptheant.org, which is our statewide little fire ant awareness website. Okay, the last species we'll talk about is rapid ohia death. Rapid ohia death is a fungus. It's a vascular fungus that affects ohia trees, among other species, but it's particularly virulent on ohia. Essentially, it clogs their vascular system. It's kind of like grows within the phloem and xylem and cuts off water flow and nutrient flow throughout the tree. So the tree can be infected for several weeks, and then suddenly it will die for several months, and then it will start to turn brown and die within about 2 weeks. So you can see in this cross section some of the staining that's indicative of a rapid ohia death. Down on the bottom, these are some aerial photography of Hawaii Island, where there's a fair amount of rapid ohia death, but it's all in low elevation. And this is a close-up of a tree. So again, reporting is critical to get ahead of it. Rapid ohia death on Maui, as of August 2019, there was only 1 tree that was detected. This was again reported by a community member. It's the first detection and only detection of it on Maui. We have crews out looking regularly. The State Department of Land and Natural Resources flies helicopter surveys. You can see some of the helicopter track lines down here on the left, looking for affected trees. But it's something we really encourage people to do, is to adopt an ohia, take a look at, monitor it, and report it if you see any indication of browning or sudden death. And then we can follow up. If you are working with conservation organization, of course, you know who to report it to, but Ms. Kendall's reports through the community. We'll send Mike Aid out to come collect a sample and send it in to a lab in Hilo to get tested. To prevent the spread, there's a quarantine on movement of ohia from Hawaii Island, but the most important thing that you and I can do is to decontaminate before we go into the forest. So cleaning boots, cleaning gear, rubbing alcohol kills the fungal spores. So one of the concerns is that the fungus can be spread as soil is spread. Basically, ambrosia beetles will produce frass that falls on the ground and then it's tracked. And so by cleaning your gear, you can keep it out of the forest. Again, there's lots of information because it's a relatively new disease. There's lots of information coming out regularly. Scientists are doing their best to discover new techniques and how to contain it and address it and share that with the resource managers throughout the state. So rapidohiadeath.org is a resource to learn more, as well as the Rapid Ohia Death Facebook group. Okay, this is different, of course, than ohia rust. Ohia rust is a leaf fungus that affects, it's named ohia rust because it does affect ohia, but it's also the reason that rose apple, which is a relative, it's in the same family as ohia, is mostly dead along the Hana Highway. So you'll see these big patches. This is in Haiku area. This is Puccinia cii. It causes orange spots on ohia, but then will oftentimes kill. It does affect, different strains do affect ohia to some degree. And it's actually the reason that there is a ban on importing cut foliage in the myrtle family. So other Myrtaceae, because out of concern that this could spread and a new strain could be could do this. What happened to rose apple could happen to ohia. So again, this applies to invasive species in general. Biosanitation, preventing these species from getting there in the first place. So cleaning your gear. If you're going up into the forest, go Mauka to Makai. Mauka tends to be the more pristine areas, and then you try to go down. If you're taking guests or you're leading tour groups up into the forest, have them brush their boots, clean their boots before they go up. People go inter-island, people bring seeds back and forth, and the same thing applies. For example, summit of Haleakala, sometimes there's certain plant species found native to the Northwest because people put on their warm, fuzzy fleece jackets to watch sunrise and the seeds blow out of their jackets or whatever and end up growing up at the summit of Haleakala. And then they're detected early and taken care of. But decontamination is critical, biosanitation. And then reporting early. So there is, of course, the 643 pest hotline. So that's a phone number that goes to Department of Agriculture. 643pest.org is an online report form that's anonymous and can be used for any invasive species statewide. And then any of the species I talked about today can be reported to MISC through our website or by reaching out to us. And yeah. Again, I think I've got, I went 3 minutes over. Okay, I can have a few minutes for questions. Let me stroll through here. Has there been any research done on genetic manipulation or control of any of these invasive species? That would be fantastic. Yes, to some degree. So I think there's some promising tools that would work for insects, in invertebrates, I should say, but some of these other species, it might be a little bit more challenging. So yeah, that's an interesting topic. Unfortunately, I think one of the challenges with invasive species management is that a lot of there's the trickle-down effect with new advances in technology. Some of it trickles down to the more poor budget, I guess, not to say that, but ways to address invasive species. It said, yeah, don't release your pets. Okay, so Catherine was talking about on Big Island, there were mice and water turtles. Sides on cages at pet stores say, don't release the pets. That is a great idea. It was actually a strategy that we were using statewide for a while. There was that habitatitude that Department of Aquatic Resources was using. And then it was, contain your pets. But it's time to revisit that because there's definitely pet trade inevitably leads to the presence of pets in the wild. So I think that in Florida, that's what they found is all of these species that came in through pet trade escaped things like pythons and things like that now plague the Everglade. Okay. Thank you. Let's see any other, I'm going to stop my slide share. Here. Okay. Oh, condos and groundskeepers, do they report in observations? We've encouraged them to. We actually did a project that was funded by Hawaii Tourism Authority where we went around to hotel groundskeepers and did trainings with them on recognizing invasive species, specifically little fire ant. So it was a little fire ant specific program. And then encouraging them to report. And to some degree, yeah, I mean, we do actually, get reports from groundskeepers and things like that. But there's always room for more and continued education because there is an audience like you. It's a good point. They're likely to detect these species because they're working outside and handling these things all the time.